Welcome. In this video I'm going to show you how you can obtain the Wilcoxon signed rank distribution with Python and the so-called shift algorithm. I have a separate video where I explain a little bit more about the distribution itself, and I also have other videos for different methods. The easiest one I think is to simply use my own library, which has two dedicated functions for it. But in this video I'm going to show you how to use that shift algorithm. I've copied here basically the steps that are involved in that, and we simply go over those. I'll use as an example a sample size of 6, so let's load that in. And we need to start with listing all the values from 0 to the maximum possible, which is the same as n times n plus 1, and then divided by 2. So that's being done over here. And then list all the possible values, so range 0 to maximum of ranks plus 1, because the range excludes the maximum value here, so but we do need it. And then we can just simply show it as a list. And indeed here now we have 0 to 21. Alright, we need to have a vector with a value of 1 followed by n times a 0. So, and actually it's still n times because we also have that 0 in there. So what we can do is we simply say, well, a 1 and then add a 0 and then the max number of ranks, which is that 21. And that should give us a first vector, as it were, of a 1 followed by all those zeros. Then we shift all of these by 1. So this 1 goes one place further, and that means this one drops off and is actually then added in the front. So we can do that with this nice little trick over here, and that should give us then 0 and 1 and then all the other ones. And now we add the results of this one and this one together, which is fairly easy to do with Python. And we have our new list of frequencies. So now we do this again. We shift by 2. So the same steps as before. We shift, and the only number that could change was the 1 from a 2. So it was a 1, and now that's a 2. And here it's a 1, and here it's a 2. So the rest stays all the same, and now all of these should actually shift up 2 places. So these 2 actually move over here, and these last 2 will then move up front. So hopefully that worked, and indeed we have twice a 0, twice a 1, and the rest all zeros. We again add the last 2 results, so that's these now added to these, and that gives us the first 4 values all being a 1, followed by all zeros. And we actually keep doing this until we've done this n times. So I simply copied all the steps 3 times, 4 times, 5 times, 6 times, and then we print the final result. Alright, so this is actually our frequency distribution for the Wilcoxon signed rank test. Now we usually don't, so all these steps might look a little bit tricky, so I made a small animated image that can actually show you all the steps. We usually don't want just the frequencies, we want the probabilities, and those are simply done by dividing the frequencies by 2 to the power of n, which is the sum of all of them. And then we can simply have, for example, if I wanted to know the probability of having a sum of ranks of 3, so my t value is then 3, I simply divide the corresponding frequencies of that t value over 2 to the power of n, and that's apparently about 3%. For the cumulative one, we simply sum them all up to and including that t value. So that's why there's this little plus 1 over there. And we get our cumulative density function, as it were, showing us that there's a 7.8% chance of having a sum of rank of 3 if you have a sample size of 6, I think it was. Alright, and that was it. I hope this video was helpful, and thank you for watching.